Appium is one of the most widely used frameworks for mobile automation. It's powerful and reliable, but writing tests often means spending time finding locators, handling selectors, and debugging UI elements. That's where the Appium MCP Server makes a difference. It lets you create test scripts quickly without the hassle of manually locating elements. You just describe what you want in plain English, and it handles the automation steps and locator mapping for you. If you look up Appium MCP Server, you'll come across several NPM packages and GitHub repositories. After reviewing many of them, two stood out. One from the Appium Test Distribution Project and another developed by Sergey Gavrilyuk. In this video, we'll focus on Sergey's version since it offers a simpler setup. You can get started just by adding the NPM package to your existing automation project. Before getting started with the Appium MCP Server, it's important to have all the components needed for manual Appium scripting already set up. That includes Xcode for iOS, Android Studio for Android, the necessary simulators and emulators, and of course, the Appium server installation. You'll also need Node.js, VS Code, and GitHub Copilot. To write an Appium test, we need to choose an Appium-compatible client library. The best maintained library and the one the Appium team recommends using is WebDriverIO, so let's use that. To install and initialize WebDriverIO in your project, run this command: npm init wdio at latest period. This interactive setup will prompt you with several questions. Answer based on your project needs. When asked about the type of environment, select mobile. When prompted to choose a service to add to your test setup, select Appium. I'll skip the Appium setup part as I already have Appium Server and drivers installed on my machine. Once the setup is complete, it will generate the necessary files, including a WebDriverIO config file in your project root. After generating the initial files, we'll restructure our project for better organization and flexibility. Create an app folder to store your mobile app files. In this example, I'll be using a demo app provided by the WebDriverIO team. Create a config file for Android-specific configuration. Update the Appium app configuration value to point to the current file path. Next, create a config file for the iOS-specific configuration. Point it to the current iOS app file path. Remove the default device capabilities value that was added by the WDIO setup. Now it's time to set up the Appium MCP server. Install the Appium MCP NPM package. Create a capabilities JSON file with your desired device and app configuration. These capabilities will be used by the MCP server. In the VS Code system configuration folder, create a JSON file named MCP with your MCP configuration. This file tells the MCP server how to connect to your Appium setup. Start the MCP server. In the Copilot Agents Tools section, remove any unnecessary servers to keep the context clean. I'll also add a Copilot instructions markdown file inside the GitHub system configuration folder. This file provides the MCP server with guidance on how to handle automation requests and what rules to follow when generating test scripts. In this case, I've instructed the Copilot to create test cases using the page object model pattern. I have also provided code samples for writing POM and specs files. I'll also set up a proper test folder structure to help guide the AI in generating well-organized test scripts. We're almost ready to use the MCP server. Before that, start the Appium server and launch the Android emulator. Here's the prompt I'm using to describe the flow I want to execute and generate a test script for. Start an Appium session and launch the app on an Android emulator. Click on the Forms tab and enter the text ABCDF into the input field. Toggle switch and verify the status. Select the value. Appium is awesome from the dropdown. Click on the button with text active. Click on OK on the displayed pop-up. End the session. After completing the above steps, write all these steps as an end-to-end test case using Appium and WebDriverIO. As soon as I hit the Run button, the Copilot agent started working. It recognized that it needed to use the Appium MCP server and asked for my permission to access the server. Once I granted permission, it began executing the specified steps. For each step, it requested my approval before interacting with the screen elements. The agent successfully entered the input text, toggled the switch off, selected a value from the drop-down, clicked the active button, and then pressed OK. After completing all the steps, it analyzed my codebase to understand the folder structure and automatically generated the page object model along with the corresponding script files. Now, let's take a look at the generated code. It appears well-structured and neatly organized. Next, I asked the Copilot agent to run the test. It initially ran into an error, but quickly identified the necessary change in the main configuration file. After making the adjustment, it successfully executed the generated test script. Congratulations! Your first test script has run successfully without any manual element identification or script writing. Now, let's try a different flow, this time running the test on the iOS simulator. Here's my prompt. Start an Appium session and launch the app on an iOS simulator. Go to the Swipe tab, swipe through the displayed card, and extract description text from all cards. After completing the above steps, write all these steps as an E2 test case using Appium and WebDriverIO. After I hit the Run button, the agent began working. It detected that it needed to use the Appium MCP Server and requested my permission to access it. Once I granted permission, it successfully executed all the steps and generated the test script. Now, let's review the generated code for the swipe test. Once again, both the POM file and the spec file look clean, well-structured, and neatly organized. Next, I asked the agent to run the test. It encountered a few errors but quickly determined that the script needed some updates. After applying the necessary changes, the agent successfully executed the test on the iOS device. With the help of the MCP server, I was even able to automate a complex drag-and-drop scenario using simple English instructions. It's impressive how plain language commands are transformed into working automation without any manual locator searching or repetitive coding. Try it out yourself and experience how MCP Server can accelerate mobile test development, making script creation faster, cleaner, and nearly effortless. Happy testing!